Right now, you are looking at thousands of discarded plastic water bottles scattered across a cold concrete floor. To most people, this is just waste. Empty bottles, crushed plastic, forgotten packaging from modern life. But inside this advanced recycling mega factory, every single bottle is about to begin an astonishing transformation. What starts as trash will soon become strong recycled polyester woven into military-grade eco-canvas and finally turned into a rugged, waterproof backpack built for the outdoors. The journey begins inside a massive warehouse where compressed bales of used plastic bottles arrive from recycling centers across the region. A huge industrial crane moves overhead, lifting towers of plastic bales like blocks of frozen garbage. Each bale contains thousands of bottles tightly packed with steel wire waiting to be released back into motion. The first machine in the line is a powerful bale breaker. Sharp steel blades tear through the compressed blocks, ripping open the wires and unleashing a flood of bottles onto a fast-moving conveyor belt. From here, the plastic enters a multi-lane sorting system. Robotic arms, optical sensors, and air jets work together at high speed, separating clear PET bottles from colored plastic metal pieces, caps, labels, and unwanted contaminants. Only the cleanest clear plastic continues deeper into the process. Next, the bottles pass through a high-pressure hot water tunnel. Turbulent water sprays from every direction, blasting away dirt, glue paper labels, and surface residue. The plastic then tumbles inside a massive washing drum where soapy water churns violently around millions of bottles. This is not gentle cleaning. This is industrial purification. Every surface is scrubbed, rinsed, and prepared for the next stage. Now the bottles enter one of the most satisfying machines in the entire factory, the heavy-duty shredder. Inside the chamber, rotating steel teeth crush and slice the bottles into tiny, transparent flakes. In seconds, bulky bottles become a rushing stream of uniform plastic fragments. The wet flakes pour into a centrifugal dryer, spinning at extreme speed to remove water from the surface. Then they move through an advanced optical sorting matrix. Ultraviolet lasers scan the flying flakes in milliseconds, detecting microscopic impurities that the human eye could never see. Any contaminated piece is instantly rejected by a burst of air. What remains is pure, ice-like recycled PET flakes. Clean, clear, valuable. But this is still only the beginning. The flakes are loaded into a towering, preheating vacuum silo where moisture is removed before melting. Inside the extrusion system, twin screws rotate with tremendous pressure and heat. The flakes slowly soften, collapse, and melt into a crystal-clear liquid plastic. This molten material is pushed through a custom die, forming long, continuous strands that look like transparent plastic noodles. The strands pass through a cooling water bath, hardening almost instantly. Then high-speed rotary blades chop them into perfectly uniform recycled plastic pellets. Millions of tiny, translucent pellets bounce and flow through the system like industrial snow. These pellets are the new raw material. They travel through pneumatic tubes into smart storage silos ready for the next transformation. Now the factory shifts from recycling into textile engineering. The rPET pellets are delivered into melt-spinning columns where they are heated again until they become molten polyester. Inside the spin pack, the liquid plastic is forced through thousands of microscopic holes. From each hole emerges a thread so fine it is almost invisible. A powerful stream of cold air solidifies these liquid streams into delicate eco-fiber filaments. At this moment, plastic waste becomes fiber. High-speed Godet rollers pull the strands forward, stretching them to increase strength and stability. The fibers are gathered, drafted, and combed into a thick white web. Then crimping gears add texture, turning the flat fiber into a soft, cotton-like mass. This fluffy, recycled material is compressed into huge, rectangular bales, each weighing hundreds of pounds. But the factory is not finished. The bales are opened again and fed into carting drums covered in tiny wire teeth. The fibers are aligned, combed, and drawn together through spinning funnels. At nearly 15,000 rotations per minute, loose recycled fiber becomes strong eco-polyester yarn. Thousands of automated winding bobbins spin in perfect synchronization, creating massive spools of clean white yarn. From here, the material enters a futuristic weaving hall. Rows of ultra-fast looms move with hypnotic precision, crisscrossing yarn into heavy-duty canvas fabric. The fabric is engineered to be tough, flexible, and durable enough for outdoor gear. Once woven, the continuous canvas roll enters a dyeing machine. A rich olive-green dye bath saturates the fabric, giving it the rugged outdoor color of a premium tactical backpack. Thermal setting rollers then bake the material under controlled tension. This locks the fabric structure, preventing shrinking, stretching, and distortion. After that, automated spray nozzles apply a non-toxic waterproof nano coating across the moving surface. Tiny droplets cover the fabric evenly, creating a protective layer designed to repel rain, mud, and moisture. At the end of the textile line, a robotic arm winds the finished eco-canvas into a massive commercial roll weighing nearly 2 tons. The recycled plastic has now become premium waterproof fabric. But fabric alone does not make a backpack. The giant roll is moved into the cutting department where it rests on an automated material relaxation system. This allows the fabric to settle naturally before cutting. Robotic spreader tables then lay out 40 identical layers of olive green canvas in a perfectly flat stack. Clamps lock the edges in place. A computer-guided CNC laser cutter glides across the surface, slicing backpack panels with extreme accuracy. Back panels, front pockets, shoulder straps, side compartments, and bottom plates are cut from the fabric with almost no waste. Robotic suction arms lift each piece and send it into organized production bins. Now the backpack begins to take shape. An embroidery machine stitches a minimalist outdoor logo onto the front pocket using bright orange thread. Twin needle sewing stations attach heavy-duty nylon webbing to the shoulder strap templates. Ultrasonic welding blocks fuse the inner laptop sleeve layers without glue, creating clean, airtight seams. Specialized modules install rugged, water-resistant zippers onto side pocket panels. Every component moves through a smart tracking system where straps, pockets, panels, frames, and buckles are sorted into color-coded bins. The assembly line now becomes faster and more complex. Dual robotic arms grip the backpack shell, flip it inside out, and position it for structural reinforcement. Flat-lock sewing stations seal the main load-bearing seams using reinforced recycled thread. A pneumatic tool inserts thick recycled foam padding into the breathable mesh back panel. Multi-rivet presses attach anodized aluminum buckles and strap tensioners to the lower adjustment points. Finally, a robotic sewing arm performs a dense bar tack stitch across the top haul handle. This small detail is critical. It gives the backpack the strength to carry heavy loads without tearing. Then at the end of the assembly line, a robotic gripper lifts the finished backpack from the conveyor. For the first time, the product is complete. A rugged olive green eco backpack made from bottles that were once discarded as waste. But before it can leave the factory, it must survive testing. Inside the stress chamber, mechanical arms pull the shoulder straps under a 100-pound weight simulation. The seams are stretched. The buckles are challenged. The handle is tested under force. Next, high-pressure water nozzles blast the zippers and fabric surface to verify the waterproof coating. Water beads up and rolls away instead of soaking in. A robotic 3D scanner then rotates around the backpack, projecting a green laser grid across every seam edge, pocket, and panel. The system checks for microscopic stitching errors, size, anomalies, and hidden defects. Only backpacks that pass every test continue forward. A laser engraving machine embeds a unique serial tracking number onto a recycled aluminum internal plaque. A recycled cardboard hang tag is attached with a small string loop. Then the backpack enters the packaging line. Automated machines fold sustainable cardboard shipping cases without tape. A gentle robotic arm places the finished backpack flat inside the box without plastic wrapping. Inkjet printers spray logistics data directly onto the exterior packaging. Spider-like sorting robots move the boxes onto wooden pallets based on destination codes for air, sea, and ground transport. The pallets are wrapped with a thin, biodegradable eco-stretch film, then transported by autonomous guided vehicles across the vast factory floor. At the loading dock, massive warehouse doors rise open. Morning light floods the clean industrial space. Electric cargo trucks wait outside, ready to carry the finished backpacks to stores, warehouses, and outdoor adventurers around the world. And finally, the backpack appears in a commercial studio setting. It stands proudly on the minimalist concrete pedestal. Olive green fabric, orange aluminum buckles, clean stitching, waterproof finish. A product born from waste, rebuilt through science and engineered for the modern world. On a forest trail, a stylish hiker adjusts the backpack straps. Rain begins to fall. Water droplets slide effortlessly across the recycled fabric surface. Not soaking in, not slowing down, just rolling away. This is the hidden journey behind one eco backpack. From discarded plastic bottles to high-performance outdoor gear. From pollution to protection. From waste to something worth carrying.